Let us start for another lesson here. Or how can we measure the oxidation number of the elements inside the molecule. But today, inshallah, we'll talk about oxidation and reduction in the chemical reaction. Oxidation and reduction in the chemical reaction. Let us start by the easiest equation. Look at this one. Now, if we have hydrogen molecule and gas reacts with oxygen as gas to produce water H2O as liquid. At first, we should know how can we make the balance to normalize this. 2 hydrogen, 2 oxygen, only 1 oxygen, so it will be multiplied by 2. That means we have 4 hydrogen here, it will be by 2. But actually, you should know, this balancing not acting upon the oxidation number. I'll repeat again. The balancing this balancing has no effect on the oxidation number. So let us start one by one. At first, classify this one or separate by this one. H2 converts to H2O, and the second O2 converts to H2O. One by one now. The oxidation number of any element in its molecule, oxidation number of any element in its molecule equals 0. When you check here hydrogen with oxygen in water, it is -1. We did this one before. Or positive. Which one will be better? Is it negative or positive? I put here one. What is negative or positive? Negative. I'll give you, okay, hydrogen and oxygen, 2.1 and here 3.5 for electronegativity. So electronegativity of oxygen is more, so it will be negative, but here it is positive. Don't forget this one. It's okay. Now, hydrogen here is +1. It's +1. 0 converts to +1.
How?
From 0 to +1. From neutral to +1. So in this case, lose electrons, right? So it will lose. Lose electrons, that means oxidation process. Oxidation process. Okay, it takes place on hydrogen. Oxidation process takes place on hydrogen. That means hydrogen is a reducing agent. Remember this? Yes. Let us check oxygen. I'll repeat the same sentence again. The oxidation number of any element in its molecule equals 0. Oxygen here, +1 times 2, that means +2. So oxygen should be -2, right? 0 to -2, that means it gains 2 electrons. Gain. The meaning of gain, that means reduction process. Therefore, oxygen O2 is an oxidizing agent. Okay? Don't forget this. Oxidation process on reducing agent. Reduction process upon an oxidizing agent. Okay? Another one. Let us check here sample spot. Will I put as example sodium Na reacts with water H2O to produce NaOH, sodium hydroxide, and hydrogen gas evolves. We make this equation before and the reaction itself. Right there, when we put sodium on water, but exactly don't forget, in the lab, put water on sodium. Okay? Now, 1 Na balance. 2H, H1, H2, that's mean 3. How can we make this balance? I said that before. We find H2 as even number, converts to H1 and H2. This one is even, but here is odd number. Take the odd number and multiply by 2. Multiply by 2, that means we have now 2 hydrogen and 2 hydrogen. So it will be 4. Multiply by 2 to make this one 4, right? How many sodium now becomes a 2? So it will be 2 here. It's okay? Now, after complete this balancing, let us check now oxidation and reduction. 1 by 1. Make half like this. And we have sodium, Na, converts to NaOH. And also H2O converts to H2. And don't forget, there is no effect of balancing on oxidation number. There is no effect of balancing on the oxidation number. Let us check here. Do you remember I said that before? Oxidation number of any element in X molecule equals 0. But here, sodium is positive 1. And oxygen -2, hydrogen +1. When you count all of this, +1, +1, -2, all of them should be 0, right? Let us check sodium only. From 0 to +1, that's mean lose, right? Losing here, therefore, oxidation process. Oxidation process, that means sodium itself, Na, is a reducing, excellent, reducing agent. Okay, let us check here hydrogen. Hydrogen in water, we said that before, don't forget it, it will be +1, right? Back again to the electronegativity. Check here, electronegativity of hydrogen 2.1, electronegativity of oxygen 3.5. So, oxygen has electronegativity more than hydrogen, so it can attract electrons to itself more than hydrogen. That's means oxygen negative and hydrogen positive. It is not complete negative, it is partial. It is partial. Now, back here to the equation again. Hydrogen here is +1, but hydrogen in X molecule equals 0. From +1 to 0, that means gain electron, gain negative, right? Gaining electron, therefore we can say this process is reduction process. So, water in this case, H2O, totally, right, is an oxidizing agent. Okay? Now, let us check here. Replacement, that is simple replacement. Simple replacement. It will be oxidation and reduction. process. Redox, reduction and oxidation. Okay? And combination here, or cranking, decomposition, the opposite of this, oxidation and reduction. What do you think will change the equation and the reaction itself? Look at this. If I put here sodium hydroxide, NaOH, aqua solution, the middle of aqua, don't forget, it has water, right? Plus HCl, hydrochloric acid, another aqua solution, that's mean base, and acid, that's mean neutralization, right? To produce NaCl, sodium chloride, okay, aqua solution, and H2O, water as liquid, salt, and water. In this process, acid and base neutralize to produce salt and water. That is neutralization process. It's look like double replacement, not single replacement like sodium and water. It is double replacement. Let us check now. Sodium here, positive 1, oxygen, negative 2, hydrogen, positive 1, hydrogen, positive 1, chloride, negative 1, sodium, positive 1, chloride, negative 1, hydrogen, positive 1 times 2, oxygen, negative 2. Let us check one by one. Sodium from positive 1 to sodium positive 1, is there any change?
No.
No. Oxygen from negative 2 to negative 2, is there any change? No. Hydrogen from positive 1 to positive 1, is there any change?
No.
No. Chlorine, Cl, negative 1 to negative 1, is there any change?
No.
So, it is this reaction called redox or no redox? No redox. In double substitution or double replacement or neutralization process, there is no oxidation, no reduction, that means no redox. No redox. It's okay? Thank you, sir.